Hi friends, welcome to Coding with Sonali. So today in this session, we will be studying about the pointers as well as the 1D array, how pointers works with this one-dimensional array, that is 1D array. So now let's see first what is this one-dimensional array, that is 1D array, quickly, because we have already seen in details about the 1D array in the earlier session. So 1D array. So in case if we are having the 1D array of integer type, so this is the 1D array because it is having one subscript, that is one dimension. Here the size of the array, this is fixed, we cannot change it runtime. So we are mentioning the size as 5 and we are also initializing it with these values. These are the elements. We know that in case of the array, the elements are located in contiguous memory location and the elements are placed from the index 0 to n-1. So how they are represented in the memory? We know that in case of the memory, it is a long tape of bytes. So here, first of all, the memory is in hexadecimal form, but I will, for simplicity purpose, we will give the different value. Now, how these elements will be stored here? So suppose you are having here 200. Since this array is of the data type integer, all elements will be of the data type integer and integer takes 4 bytes. So therefore we 104, 200. So these elements, let us say 1, 2 and index 0, 1, 2, 3, 4. So you can see after every 4 bytes the next element starts, because first of all elements are stored in contiguous memory location in case of the array and only 4 bytes are occupied for each of the elements. So if there are 5 elements, so 5 into 4 you have to multiply with that. Total 20 bytes. This is the compile time initialization of the 1D array and how it is represented in the memory, that is a physical representation. Now the couple of things with this 1D array is that name of the array, that is ARR. It is also called as a base address, also called as a constant pointer. So constant pointer means pointer which cannot be changed to point to other variable. So that means we know that the base address will have the address of the 0th element of the array. So since we have seen actually that the address was present starting from 200 and 204, then so ARR will have the value that is 200, will have the address of the 0th element of the array. So at 0th index this 1 is present, so the address of that is 200. So that is the base address and it's also called as constant pointer. You cannot change this pointer to point to the other location, and that is the thing it is said that you cannot perform incrementation as well as decrementation on this array, that is base address, because this is a constant pointer. You cannot change to point to the other variable. In case of the 1D array, first of all, this you don't mention the size at the compile time, but you initialize it, this will work. But if you are not initializing it, that is you are just declaring it and you're not initializing it, then this will not work, because you have to specify the size if you are not initializing. If you initialize, then there is no need to specify the size of the array. So you have to specify the size. And since the size is fixed, you cannot change the size at the runtime. So these are the disadvantage. So this is all about the 1D array in short. Quickly I have revised. Now let's see what is this pointer now. Then we will relate the pointers with the array. We'll write a program. We'll see how to access the array elements using the pointer. Now in case of the pointer, first of all let us see the definition of this pointer. Pointer, it is the variable which will contain, whose value is the address of the other variable. So it is a variable and its value is the address of the other variable. Normally what happens whenever you are having any variable, say a is equal to 10, right? You are having suppose this variable. So you can see here this variable is of the data type integer. That means it can hold the value which is of the data type int. So this is 10 and it is of data type int. But in case of the pointer, how it is declared? Like that it is declared. So this pointer, first of all, it will have the value as the address of the variable. So it means what? Suppose you are having integer a is equal to 10 and then you are taking a pointer and the value what you are storing here is, so you can see here what does it mean? It means that first of all this pointer, that is p, this is a variable, so it is having what value it is having? It is not having the value as 10. No, it cannot hold. It is a pointer. It should contain the address. So it is containing the ampersand that is having the address of this variable. So suppose this is your a and it is having 10 value and it is having 100 location. So what will be the pointers? Pointers is also having some other address in the memory. So pointer is pointing to this a, that is it have to hold the address of this value. So therefore what it will hold? It will hold the address of this a, that is 100. So its value is 100. So but in case of the a value is 10. So I hope so you understood. So this is what whenever we will use the pointer, you will come across this address of operator. This is one of the operator which is used with the array. Here you can see this is as int star p, that is a integer pointer. So therefore it will be having the address of the variable whose data type is integer. It can happen that if we are creating like this, what does it means? This is a char pointer. That means pointer is having the address of the variable whose data type is character. A pointer is having the address of the variable a and I have to access the value of this address. So this address is what? It is 100. P is having what value? It is having value as 100, that is address of other variable. So we are having that. Now we are having the access to the address of that variables. Since we have the access to the address of that variable, how to access the value of that variable by that address? Through pointer. So simply by using this indirection operator, that is star before p. So you know that first of all p is what? P, if I just print p will give me just, if I'll print only p, what does the p should give me? First of all, to print the value of the p, we have to use the format specifier as %p, because this p is first of all having the address of other variable, right? So it is having the address, so we have to give this p format specifier p, or you can also give %u. We want the value, what value is present at that address. So it is having address as 100. P is having the address as 100. So in this address 100, what value is stored? So to print that, indirection operator. So p is what? P is 100, because p is holding the value 100, that is the address of other variable. Now to access the value at this address, we have to simply give star, that is indirection operator. As I told you, if we deal with pointers, you will come across this address operator, ampersand, and another operator, that is star. This is all about the simple basic things about the pointers. So what operations can be performed on the pointer? So first of all, we can increment, we can decrement also the pointers. Then we can subtract the integer from the pointer. What does it mean? It means suppose I am having like this and then I'm initializing like this. Now here in the memory I am having this a, this value is 10, and suppose this address is this, and this p, it is also having other address. And but what is this p? Since I am writing here in this line as p is holding the address of this variable a, what the p will have. You can perform different operations on the pointer, that is allowed. So you can do p plus plus, yes, this is allowed. You can also decrement the pointer, that is also allowed. You can add integer to the pointer and you can also subtract integer to the pointer. So what is this? First of all, what result you will get if you p and you are adding 1, that is this. What does it mean? So what p is having? P is having 100, that is the address of this variable a. So therefore what you are doing? 100 plus 1. So can you tell me what should be the result of this? So if you think that the result is 101, no, the result is not 101, not at all. So then what will be the result? So since this is a pointer, first of all 100, and this is a pointer to what? Integer. We know that in case of the integer, it takes total 4 bytes. So whenever you are adding 1, so this is the address first of all, that is 100, and you are adding 1 to it. So therefore total 4 bytes should be added to it. So that is, it should be in this manner, 100 plus you are adding 1. So that is 1 into size data type. And that is simply 101 into 4. That is 104. So this should be the value of this. Suppose if you are doing like this, what should be the result of that? P plus 2. So first of all, P is what? 100. 100 plus 2. So that means what? Again the same thing, that 100 plus 2 into size 4. That is total 108. I want you to calculate what will be the result of. So I hope so you will be getting what should be result of P plus 3. Please write the result in the comment box. I will be seeing it. If any issue, then you can just ask me. Also you can try with this P minus 1. Give me the result in your comment box. That will be fine. Like I'll understand, yes, you are getting the points with the pointers. Also you will understand actually, as many of them will be replying, so you can understand everybody is facing. It's not a problem even if you are doing the mistake, because we learn from every mistake. In each and single mistake we learn many things from that. So that is well and good, because you'll practice more in that case. So these operations are possible with the pointers. Now in case of the pointers, you cannot add one pointer to the another pointer. You can add an integer to the pointer. Here we had added an integer to the pointer P, but you cannot, if there are 2 pointers, you cannot add the 2 pointers. If you have you cannot multiply the 2 pointers. That is not at all possible. So in case of the array, as I told you that the name of the array, it is a base address. It is also called as a constant pointer. It cannot be changed to point to other variable. It cannot have the address of the other variable. So it is, since it's a constant pointer. So in case of the array, incrementation, decrementation is not at all possible. But in case of the pointers, the incrementation and decrementation of the pointer is possible. So this is a major difference between the array and the pointers. So this is also asked in case of the interview and the placements. What are the difference between the arrays and the pointers, and what operations can be performed, whether on the array you can increment or decrement, whether you can change the address. So you will be getting all the answers of this once you go through this video. Now let's write a simple program to access the array elements using the pointers. How to access the array using the pointers? So first of all, this is your main function. We know that whenever you execute your C program, the entry, that is the control, comes in this main function. It is an entry point to start an execution of the C program, and line by line instructions will be executed in sequence order. So first line, you have simply create an array of size 5 and you have initialized it with these values. It is an integer array, and now you are taking a pointer that is in star P. So here you can give like this also, since we know that name of the array is a base address itself. So P is equal to ARR. So it is also pointing to the 0th element of the 1D array. Suppose you are having this 1D array like this, 116, 220. Now this is your ARR. So when you give this P, so P is also pointing here. So P is also having the address that is 200. You are giving this, it is also pointing to the array. Now since this is a for loop, yeah, so since I have to access this array using this pointer that is P, so how to access? So I am taking a for loop first of all, and I will run this for loop till the size of the array elements, because I have to access all the elements of the array using the pointer. So therefore int I is equal to 0 and I less than 5, that is the size of the 1D array, and I plus plus, and inside this for loop I am giving a display message. So we know that we are in case of C, we are using the printf to display the message on the console. If we have to display the value, we mention the format specifier. So %d is to print the value that is of the data type integer. therefore %d, and /n is, you will get it on the new line every time when this loop runs. So /n is on the new line. And what value I am giving? Star in bracket p plus I. So since I told you what does the star mean, star is what? Indirection operator. So whenever we know that first of all pointer is having the value as address of other variable, we have to access the value at the address which pointer is containing. So here the pointer is containing what? Pointer is containing 200, right? If I have to access the value at the address 200, then I will use this asterisk, that is indirection operator. So I will get the value as 4 because at 200 this 4 is present. So why I am taking like this star p plus I? Because I am taking a iteration of for loop. Initially when I is equal to 0, this is what? This is simply star of p plus 0. Therefore simply it is equal to star of p. Star of p is what? We have seen it is 4, right? So I will get 4. Next time I have to print other elements. So this I gets incremented, I becomes 1. So therefore what will be the scenario? In that case it will be p plus star of p plus 1. Since I told you whenever we are adding any integer to the pointer, so this pointer is first of all having the value 200 and you are adding 1. So it will be not 201, it will be depending upon which pointer it is. Since it's an integer pointer, therefore the size of the integer is 4 bytes, and therefore simply 200 plus 4 will give me 204. So simply star and 204. So what is the value at this 204? The value is 3. So next time you get the value, you get 3 to be printed. Then when I becomes 2, then it will be what? It will be simply star of, so what will be this? This will be 208. So that is what? 2. All the elements we can print of the array using this pointer, right? I hope so you understood. Also how you can represent this star of p plus I? Simply you can also represent it as like this. Same like the array subscript. So the name of the pointer p and the subscript. So p of 0, that is when I is equal to 0. If I don't write this star of p plus I, if I simply write like this, in that case what will happen? So p of 0, it will give me this element value, that is 4. Next time I gets incremented, I becomes 1. So p of 1 will give me 3, like that. Also you can represent like this, that is outside I and in square bracket p. So these are different ways how you can access the array elements using the pointer. And that you are aware actually by the array subscript how we are accessing. We have already seen that is either a of I or I of a. Also we can use the same like this also, star of a plus I. So all these things, by this you can get the access to each elements of the array. So this is how to runtime initialize the array using the pointer. We will be seeing how to write a program in C language, runtime initialization. So you can see this is a main function. We are declaring the array and we are giving the size as 5. Then we are taking a pointer by the name p, and this pointer is pointing to this array itself. Then what we are doing? We are taking a for loop. So runtime we will ask user to enter the value and that we will be filling in the array. So what will happen now? So we have taken the for loop. So for loop, obviously since the array element size is 5, we are taking the size as I is equal to 0, I less than 5, I plus plus, and we are asking, that is printf, enter the element. So user will understand, yes, user have to supposed to enter the element. Then we are using the scanf. So in case of the C language, we use scanf so that the user will give the input on the console, and that input we will be collecting in the address of the variable which we are using. So simply in case of scanf, how we give, the first thing we give the format specifier, and we give the second thing as the address of that variable. So you can see here, since we have to utilize the array elements runtime, this is runtime, we are asking the user to give the input on the console using the pointers. Therefore what I have given here, p plus I. So you can see here, what is this p plus I? P is also pointing to array. So it is having the address of the 0 element, right? And plus I. So initially when I is equal to 0, in that case p plus 0, that means it will simply give the address of the 0th element. So you can see here I am not using ampersand before this expression. Normally whenever we use the scanf function, we always give the address and that variable because we want the value to be stored at that address. But since this is a pointer, this is itself a address, so therefore we don't require to give the ampersand. So therefore it was just p plus I. So that is initially I is equal to 0. So this will be simply, this will be as p plus 0. That is simply, suppose I am having the address to be 200 and 200 plus 0. So at this address, I am collecting the value which the user is entering on the console. Then the next time I gets incremented, I becomes 1. Then again p plus 1, so 4 byte. So that is at 204, we are collecting the value which the user is entering on the console. And in this format, I will be taking the input from the user and I will be storing in the addresses. And this is how to initialize the array runtime, because we are runtime asking the user to give the input on the console using the pointers. So a couple of things which is important with respect to 1D array and the pointers, and this is very much important. You will be asked in your interview. Consider this 1D array by the name ARR, and we are having, since we know an array indexing starts from 0 to n minus 1. So, and each index, these elements are present, and we are having one p. So, p is a pointer, and pointer is having the, it is pointing to this array. So, therefore, this, it is holding the address of this array, that is 200. This is having the value as 200. If I give like this, and if I give this like this. So a question to you, whether this ARR, you know, this ARR is the name of the array, which is also called as a base address. So whether this and this are same or not. So first of all, if you see here, if you just print the value of ARR, what you will get the value as 200. If you print the value of ampersand of ARR, the value what you will get, I want you to try, but still I will answer here itself. So address of ARR, again you will get it as 200. So in that case, both are same. These are same. That is ARR and ampersand of ARR. When you print its value, that is both of them will give you the value as 200, since it's a base address. I want you also to just write a program and to just check with these values. This is very important if you practice more with the such type of the combinations. Even if you can try different combinations. If you have any doubt, you can simply comment me in the comment box. What about this? If you this and this, whether these are same or not, that is ARR plus 1 and ampersand ARR plus 1. So ARR and ampersand ARR, they are same, right? They will print the same, that is same value, and that is the address, that is 200. But what about ARR plus 1? So since you are adding 1 here and you are adding 1 to this also. So in this case, what will be the thing? So when you perform this, ARR is what? It is simply 200. So whenever, what value will it give if you are adding 1? So it will be simply giving you 4, because it is not 201, because we know that this is one element, and therefore one element data type is what? It is integer, so it occupies 4 bytes. So therefore 1 means multiply by size of the data type. So that will be 204. But in this case, what will be the scenario? So in that case, what it will do? It will simply add actually the address actually, and if you do plus 1, so this is address of this ARR. So how many elements are present in this array? You can see here total 6 elements are present in this array. So 6 into 4 is how much? 24, right? So therefore it will add 24 to this base address. So therefore what value you will get? You will get first of all 200, but you are adding 1, since to the whole array it will add 1 more. So it will be like, it is adding to this base address the total number of the elements which are there in the array, and therefore how much it is? So these are the total 6 elements, 6 into 4, because 4 is the number of the bytes. since it's an integer, therefore 4 bytes, and therefore this will be 24. So final answer you will get it as 224. So you can see how it differs actually. Normally if you print the value of ARR and ampersand of ARR, you will get the same value, that is 200. But if you add the value actually, then this will change. It is not same in that case. This will give this value and this will add total number of elements with that it will add to the base address, and that in that case it will have the value as 224. So this is about, and this is very much important, and it is also asked in your GATE exam as well as in your interview questions in your placements. So just practice more with all these scenarios, so you will also understand it more better. Then these are the things in case of the array. So in this case, in case of the pointer, whether this and this, whether both of them are same or not, you can see here itself. What is P? P is what? 200, right? And what is ampersand of P? Ampersand of P means address of P. You can see address of P is 300. So you can understand, yes, this both are not at all same, they are different. But in case of the array, this ARR and ampersand of ARR, they are same. But the operations will be different. If you add 1 to both of them, you will get the different result. But ARR and ampersand of ARR are same. But P and ampersand of P are different. So these are the things which you should remind when you go through the 1D array as well as the pointers.